Dear students, in previous class we were discussing the uses of the dimensional equation or dimensional analysis. First one was to check the correctness of a physical relation. How we use the dimensional analysis to check the correctness of a physical relation. That means whether the given physical relation is dimensionally correct or not. To check the correctness of a physical relation, dimensionally we use or we apply the principle of homogeneity of dimensions. That is, whether the dimensions of each term on both sides of the relation are correct or equal, or we can say same or not. When we see this thing to check the correctness of the physical relation, we use the principle of homogeneity of dimensions to check the correctness of a given relation. That is, whether the dimensions of each term on both sides of the dimensions of the relation are same or not. That means if we are having a given physical relation and we have to check this correct, how we will find, how we will check the correct, we use the principle of homogeneity of dimensions, in which we see that the terms on the each side of the equation, if the dimensions on the each side of the equation are same, then we can say the equation is dimensionally correct. If they are not same, then we can say the equation is not dimensionally correct. Let us illustrate this. Illustration to show the correctness of the relation t is equal to 2 pi under root of L by G. Now let us apply this principle of homogeneity of dimensions to check whether this equation t is equal to 2 pi under root of L by G is dimensionally correct or not. Here t is the time period of simple pendulum, L is the length of pendulum, and G is the acceleration due to gravity. G is the acceleration due to gravity. Now, dear students, we will check whether t is equal to 2 pi under root of L by G. Is it dimensionally correct? That means the two sides, left hand side is equal to right hand side, but dimensionally. If the two sides are having the same dimensions, then we can say the equation is dimensionally correct. Let us check it. I will write the equation here. T is equal to 2 pi under root of L divided by G. Look here, LHS, it is T. Let us write down the dimensions of T. Dimensions of T. That is M0, L0, T. Let us mark it as equation first. Then the dimensions of left hand side are M0, L0 and T. Now right hand side. Dimensions of L. M0, L, T0. And dimensions of G. What is G? G is acceleration due to gravity. That is LT minus 2, or we will write it as M0 LT minus 2. Now we will equate. is the dimension of left hand side and dimension of right hand side. Now, what is 2 pi? 2 pi is dimensionless constant. Dimensionless constant. Mark them as equation second. From equations first and second we have. Look at t, it is equal to m naught L naught t is equal to 2 pi dimension constant, so we will not write it under root of L, dimensions of L, here is m0 LT0 divided by m naught LT minus 2. Now look here what it will become. M naught cancel, L and N cancel. Is it 2 minus 2 and here it is T0. So it will become T2. Under root square and 2 will cancel, it will become T. That means dimensions of T. So it is m naught L 0 T naught, it is T here, it is m0 L0 T. Look here, the left hand side it is m0 L0 T and right hand side is m0 L0 T. So the left hand side is dimensionally equal to the right hand side. The dimensions on both sides of the equation are equal or same. Hence, the given equation is dimensionally correct. We will write here since the dimensions on both sides are same, thus the given equation is dimensionally correct. In this way we check the given equation is dimensionally correct or not, applying the principle of homogeneity. So we illustrate here how we check the correctness of the given equation by using the dimensional analysis. So here what we obtain the dimensions on both sides. That means the dimensions on the left hand side are equal to the dimensions of the right hand side. So the given equation is dimensionally correct. Thank you.